Welcome to Brain Vision.
Okay, so it looks like we've got a block here. Looks like A and B. So let me draw this. So we got an angle 30. Oh, I'm going to write that as phi, 36.9 degrees. And then we've got a block A, which I'm just going to write A. Then we've got something on top of the block, B. Then we've got a rope here connected to the wall. And then there's an S too, which I guess is the slope. Okay, block A has a weight 3W. A weight 3W. So at A, I'm just gonna write 3W is the force acting downward. Plank B has a weight W, again acting downward, W. So I need to draw the forces acting on block A. So here's block A. Okay, so it's got its weight here. It's got a frictional force that's opposing its motion. But I guess it would have two frictional forces. So I'm going to draw that at two different levels here. There's a frictional force with S, and then there's a frictional force with B. So the weight and the two frictional forces, I think that's it. Okay, the coefficient of friction is the same. Determine its value. It's sliding down at a constant speed, which I didn't notice that. So V equals constant. So therefore, the sum of the forces must equal 0 because there's no acceleration. Let's get the forces in the direction of S. This angle right here, which would be this angle right here. Let's think about what that would be. If this continues down and this continues down, then this angle up here would be 90 minus phi. I'm going to draw it right here. I'm going to change colors here. That right there is going to be 90 minus phi. This is phi, and that's 90 minus phi. Okay, so I want to draw the sum of the forces in the S direction, in the direction of the slope, which would be this way. So that would be F sub F B plus F sub F S minus 3W times the sine, no, not the sine, the cosine of 90 minus theta, which is the sine of theta, of phi. Okay, but I need F sub FB and F sub FS. Alrighty then. So I want to continue this line here, and I need to get the normal force. So, this well, it would just be the normal force for both of these. So, if we used the sine phi here, and this is going to be perpendicular to that, then we need to use cosine phi. So, F sub FB. No. F sub NB. The normal force associated with just B is going to be W times the cosine of phi. The normal force associated with onto S is going to be the two weights, W plus 3W, which would be 4W, cosine phi. Okay, so now, switching back to red, that's going to be mu, which is the same for both of them, times W cosine phi, plus mu times 4W cosine phi minus 3W sine phi. W cancels out. Okay, so now I've got mu plus 4 mu. So that would be 5 mu cosine phi equals 3 sine phi. So therefore, rearranging, tangent phi is going to be 5/3 mu. Okay. Determine the value of mu. Wait a minute, I'm trying to figure out mu. So mu is going to be 3/5 tangent phi. Okay, so let's use the calculator here. 3/5 tangent of phi, which is 36.9 degrees. 0.45 is a reasonable answer because it's not real close to 1. It's less than 1. 0.45, we've got 3 significant digits though. 0.450. Now, the answer is in the back of the book. So let's check. And this is correct. The book says 0.452, but I don't think so, because I've got 0.450, and there are only 2 numbers given. So, no, 0.452, a 0. All right.